So now let's move into the one of the most interesting topic in data science is exploratory data analysis or EDA. In this session, we will be diving deep into exploratory data analysis. If you are a data science enthusiast or just starting your journey, this is an essential step to understand your data set before diving into any machine learning or predictive modeling. So let's start with the basics. So first of all, let's understand what is EDA. EDA or exploratory data analysis is the process of examining the main characteristics of your dataset, typically through visual methods, descriptive statistics, and simple queries. It's the detective work of data science, where you explore patterns, spot anomalies, frame hypotheses, and test assumptions using summary statistics and graphical representations. Think of EDA as getting to know your data at a fundamental level before making any conclusion or building models. Without EDA, you are essentially flying blind. So it's a crucial step for data preparation. So now let's move into the another topic, that is why is EDA important in data science. EDA plays an important role in understanding. Number one, data quality. Are there missing values? Are the data types appropriate? Do we need to clean the data? Number second is data patterns. What are the key traits in the data? Are there any obvious relationships between variables? Number third is data insights. EDA helps to uncover insights that can lead to better feature engineering, selection of models, or even the decision to collect more data. So fourth, we have data distribution. Visualizing the distribution of variables like histograms, box plot to see skewness, outliers, or ranges. Number five, and the last, we have feature relationships. Identifying relationship between dependent and independent variables, which helps in selecting features for predictive models. So in this tutorial, we will apply EDA to the house price datasets, and by end of it, you will know how to approach any data science with confidence. So topics we will cover in this session. So number one, we have introduction to EDA, which we are covering now. And number two is loading the datasets, means how to load and inspect the datasets. Number third, we have understanding the data structure, means overview of the datasets column and their types. Then after we will see handling missing data, means how to detect and handle missing values in the datasets. And then after we have data cleaning and preparing the dataset for analyzing. Then after we will see univariate analysis, examining individual features, example, analyzing the distribution of the price of house. Then after we will see bivariate analysis, examining relationship between two variables, example, price versus square footage. Then after we see multivariate analysis, looking at relationship between more than two variables, example, price, square footage, and location. Then we will be reading outlier detection, identifying and handling outliers that may skew results. Then we have data visualization techniques, using libraries like Matplotlib and Seaborn to visualize the data. And next, we will see correlation analysis, checking how features correlate with each other. And then we have feature engineering, creating new features or transforming existing ones. And the last, summary of insights, summarizing what we have learned from the EDA process. So let's begin with the first step, loading the data. For this, I am going to my file explorer. Here in documents, I am going to make a folder called EDA. Okay, so let's download the datasets from here. Okay, yes. So here we have downloaded our datasets. Okay, so now let's here I will, and in the download section I will now. Then you have to just open and open with code. Okay, even it's called. Let me. So now let me make a new file, Jupyter file. Okay. So before we start any analysis, we need to load our house price datasets. Let's jump into our code editor and begin with the basics. Here is how you load datasets into pandas data frame using Python. So number one is import necessary libraries. So let's start. Import pandas as PD. Okay. Now just write df equals to pd dot read csv csv and give the name of the, that is, housing. Let me rename it. uh, Rename, copy, and then paste here. Then after we have to write dot csv. Okay. So let's now df dot end. Okay. Df dot end. Let's see. Here we got our first 5 rows of the datasets. Once you run this code, you will see the first few rows of the house price datasets. This gives you a basic overview of what kind of data we are working with. So now let's understand the data structure. Now that we have the dataset loaded, it is important to understand the structure. We will start by looking at some key aspects. So number one is number of rows and columns. This gives us an idea of the dataset size. Number two is column types, whether columns are numerical, categorical, or dates. And number third, we are going to see basic summary statistics, descriptive statistics to get a quick idea of distribution. So here is the code to get that information. df.info So through df.info, you can get the structure and info of your datasets. The .info function provides an overview of the data types and non-null values. Then we have .describe function, which gives summary statistics for numerical columns. Okay, at this point, we will have a good understanding of the data structure, which is important for cleaning and analyzing. Okay, let's run df.describe. df.describe. Okay. So here you can see that we got count, mean, standard deviation, mean, 25%, 50, 75, and max. Here is mean means minimum. Okay. So that concludes the introduction in the first section of our EDA journey. In the next section, we will dive into handling missing data and how to clean the dataset. So let me give the topic, that is handling missing data. Let me make it some bigger. For making bigger, you can give heads. Yeah, handling missing data. So now that we have a basic understanding of our data sets, the next crucial step in EDA is handling missing data. Why is handling missing data important? So let's understand. Missing data is a common issue in real-world data sets, and if not handled properly, it can lead to inaccurate analysis and flawed models. Missing values can occur due to various reasons such as human error during data entry, issues with data collection, or simply because the data was not available. So now, ignoring missing values can lead to several problems, like bias in analysis. If missing data is not random, for example, more expensive houses tend to have missing values for some features. This can introduce bias. Second, we have incompatibility with models. Many machine learning algorithms do not handle missing values well and may throw errors. And the third is distorted result. Missing data may affect the summary statistics like mean, median, standard deviation, and leading to wrong conclusion. Now let's jump into identifying and handling missing data in our house price data sets. So the number one step we have to do is identifying missing data. So the first step is to identify which columns or rows have missing data. We can do this by using the .isNull function combined with .sum to check for missing values in each column. So let's get started. For this, like missing data equals to df dot is null dot sum. Okay. Let's run df. It's not dg, it's df. Okay. Yeah. Now let's see. We are going to display columns with missing values. Okay. Missing data. If missing data is greater than 0, then print. Let me print it. Print. Let's see what happens. In print. Oh, it's not O, it's 0. It seems that we don't have any null value. This code will, now let's understand the code. This code will give you a summary of how many missing values exist in each column. The columns where the result is greater than 0 have missing data. Okay. When we run this example, if we find that any column like bedrooms has missing values, then we need to decide how to handle these. Okay, let's understand. If we find any column and missing values, then we are going to check how to remove it. So the number 2 strategy is handle missing data. There are several ways to handle missing data, and the method you choose will depend on the nature of your data and the percentage of missing values. Here are some common strategies. Removing rows with missing values. If only a small portion of your data is missing and it is not crucial, you can simply remove the rows with the missing data. So now in my datasets there is no missing value. Okay, let me again, but I'm going to run this to make you understand. df dot df. Let me take df cleaned. Okay, df cleaned equals to df dot drop now. df dot drop now. Here we have drop now. And let's run. Okay, now let's understand what happened. However, you should use this method carefully as it can lead to loss of valuable data, especially if many rows are dropped. Okay, this will drop the four necessary rows which have none, which have null values. Now let's see other type. How can we solve this issue? This is filling missing data with mean, median, and mode. Okay, for numerical columns, you can fill missing values with the mean or median of that column. Like for categorical columns, you can fill missing values with the mode, the most frequent value. So let's see. How you can fill. Then you have to just define df. Let's take about the bedrooms. Okay, like and bedrooms. df bedrooms dot fill house data. Okay, then again I'm going to write dot mean comma in place equals to true. In place equals to true. Now just run the plot or run the cell. House data is not defined. Here we have to give df. Okay, let's write df bedrooms dot fill df bedroom mean in place function. Yes. What code is run? Now for categorical data, fill missing values with a mode. Like again, I'm going to use df any df like and then paste bedrooms, df bedrooms. Okay, dot fill now df df bedrooms again, bedroom dot mode. Okay, right within dot mode and just take 0, comma in place equals to true. Okay, now let's run. Expression cannot contain assignment, perhaps you mean double equals to, where I did in place function true. I don't think there is anything. Pause. Let's see with another column, like we have parking. Okay, let's see we take about the parking. Now we are going to take parking. Expression cannot contain assignment, perhaps you mean double equals to A. Now let's see what like the story is. Okay. Uh, so now I'm going to take stories. Okay. Stories. If I again get error, again let me write this by mistake and here dot fill now. Okay. Dot fill now. Dot fill now. df df stories dot, okay, stories dot not in 0 in place. Okay, is less equals to true. Now let's see, this behavior will change our code has run. Okay, so now let's print our df. Boom. Yes, but in my datasets there is no any null values, but you can use it into your datasets. So now let's understand what happened in this case. If the stories column has missing values, we can replace them with the average frontage size. Similarly, if the above we have bedrooms. If the bedroom column, which may be categorical, has missing values, we replace them with the most frequent bedroom type. Now let's talk about the forward and backward fill, means time series data. For time series data, missing values can be filled using the values before or after 10. So let's see. Just go to your VS Studio. Let's see df dot fill now method. df dot fill now method equals to fill equals to fill. Okay, equals to fill comma in place equals to true. In place equals to true. Let's see. This is our forward fill. Let me add comment. fill, forward fill, forward fill. Okay, just run. Yeah. Okay. Now let's say backward fill. For this, we have to just repeat the same process. Df dot fill now. Df dot fill now method equals to b fill means backward fill. Okay, backward fill. Just give comma and then in place equals to true. Okay, so we have done with forward and backward filling. So now it's time to choose your right strategy. It is essential to choose the appropriate method based on your data type and context. For example, filling missing values in a price column might with the mean might make sense, but filling missing values for a categorical column like neighborhood with a random value wouldn't. So let's understand it by having an example scenario. In our house price data set, suppose we find that bathroom, the length of the front lot in feet, has 25 missing values. Since this is a numerical column, as you can see here, bathroom, okay, and the bathroom is related to house price. We don't want to drop rows carelessly. Instead, we will fill the missing values with the mean, and it's a sensible approximation. So let's see the code for clarity. df bathrooms dot fill. Then we have df again bathrooms dot mean. We have now dot mean, okay, comma, in place equals to true. So here our code has run. It means if there will be any missing values in our bathroom, it will be replaced by the mean of the bathroom's column. The fields in all missing bathroom values with the average frontage size, allowing us to keep the rows and maintain the integrity of the datasets. So now let's come to another step, that is verifying changes. After handling the missing data, it's a good idea to check again if there are any missing values left. You can do this by rerunning the code to check for missing values, that is null.sum. Let's run df is null and sum. Let's run. Okay, here you can see that in my data sets, no one columns have missing values. Okay, this will give you an updated count of missing values, ensuring that you have handled everything. Okay, now let's recap handling missing data. So far, we have learned how to identify missing data, different strategies to handle missing value, such as removing rows or filling them with appropriate values, and how to apply these strategies to our datasets effectively. So now, here next steps come, that is data cleaning. Now that we have dealt with the missing values, it is time to move to the next critical step, that is data cleaning. In the next section, we will focus on making sure our data is in the right format, free from duplicates and ready for analysis. So now let's understand what is data cleaning. Now that we have handled missing data, it's time to dive into one of the most crucial part of exploratory data analysis, data engineering. So, first of all, why is data cleaning important? Data cleaning is the process of preparing raw data for analysis by fixing error or removing incorrect, corrupted, duplicate, or incomplete data within a dataset. The quality of your analysis and modeling directly depends on the quality of the data you provide. So cleaning the data is essential for achieving accurate result. So here is why data cleaning matters. So number one is accuracy. Ensure that your data set reflects the reality of by fixing errors. Number second is consistency. All columns should follow the same format. Example, numeric columns should contain only numbers. And third one is completeness. Data should be complete or handled correctly. If incomplete, which we did in the last session. And in the last way, efficiency. Clean data leads to faster and more accurate models. Now let's go step by step clean our house price datasets. So number one is remove duplicates. One of the first thing to check is whether there are duplicate rows in your datasets. Duplicate entries can skew analysis, especially in statistics like the mean, median, or total counts. So now let's check our duplicates rows. For this, we have to just I'm going to make duplicate rows equals to df again dot duplicated and just run. So now let's print duplicate rows. Again, in my data sets there is no duplicate. If the duplicate rows data frame is empty, then there are no duplicates. As you can see, if there are duplicates, we can remove using this. Okay, let's see. Now we are going to remove duplicates rows. Okay, so let me give the heading. Remove duplicate rows. Oh, let me mark down where is okay. Yeah, remove duplicate rows. So let's see how can we remove duplicate rows in our datasets. df equals to df dot drop. Here we are going to use drop duplicates, as you can see here, and just run. Saves. Oh, we have done with duplicate rows. If there will be any duplicate rows in our datasets, it will be removed by this function drop duplicates. So now let's verify that duplicates are removed. You can also verify this like df dot duplicated dot sum and run the cell. Here you can see that I got 0 as I told you. So now duplicate rows can occur due to errors in data collection, and removing them ensure that our data sets accurately represents the unique entries. After removing duplicates, your data set will be linear and more reliable. So now let's move into the step 2, that is handling incorrect or inconsistent data. Sometimes, even though your data doesn't have missing values, it may still contain inconsistent or incorrect data. For example, a house price column might have a negative value which doesn't make sense, and some features might have incorrect data types, such as a column need to store numbers that still contain text. So now let's understand by an example. Now let's assume in our data sets we find that parking. Okay, parking column has some incorrect values, like we can say string in place of numerics. Okay, we know that parking cannot be string like how many houses and how many parking are there in one house, like 2, 3, 4. It cannot be string. So okay, so here how can we fix this? Let's understand by an example. So first let's check incorrect parking equals to df, again df, then after we'll have parking, I will have parking, yeah, parking. Oh, let me make you understand it again. Let's understand by bedroom, okay? So let's assume that in our data sets, we find that the bedroom column has some incorrect values, like a house cannot have more than 5 bathrooms. It means if there is 5 in the rows, which is incorrect values. So we know that there cannot be 5 bathrooms in a house. So for this, what we can do is let's see what we can do is incorrect house, incorrect bedroom, incorrect bedroom, incorrect bedroom equals to df equals to df bedroom bedroom, so bathrooms, okay, bathrooms bathrooms, then we have if greater than 5 leave black, okay. Let's see what comes. Now let's print incorrect bedroom. Again we got 0 because we don't have bathroom greater than 5. If we find rows with the incorrect bathroom numbers, we can either correct the value or we can remove the value. So now let's see how can we do it. df equals to df df bathrooms small or equals to 4. Okay. So this ensured that the bathroom columns reflects reality. So now let's come to the another topic, that is ensuring correct data types. It is important to make sure each column has the correct data type. For example, numeric columns should have numeric data types and categorical columns should have the correct data type. You can check the data types of your column using .dtypes function. So let's see df.dtypes. Let's run. If any column has the wrong data type, you can change it. Here is an example. Let's see. df first take. Here I am going to take stories. Okay. df stories equals to df stories dot, okay, as type integer, as type integer. Okay, we are done. For categorical columns like we have here prefer area or furnishing status, we can convert them to variable category data type, which helps reduce memory usage, and speeds up processing. So now let's see, we are going to cover what in category cell. So DF furnishing, DF furnishing equals to DF furnishing status, furnishing status equals to DF furnish status dot h type category category. Okay, category. Let's run. Yeah. So ensuring that the correct data types are used is important because some algorithms require specific data types to function properly. Additionally, converting categorical variables to the category type improves performance in memory usage. So now let's come to the fixing outliers. Let me give the topic fixing outliers. Okay. So let's understand what is outliers. Outliers are extreme values that deviate significantly from other observations in your dataset. Outliers can skew your analysis and affect the result of your models. So let's see the example of outliers. So let's see in area. So in our house price dataset, the area area column might contain extreme outliers. For example, a few houses could be priced much lower than the majority, affecting our overall analysis. Or we can let's take it price. Now we are going to take price. Okay. In our data set, the price column might contain extreme outliers. For example, a few houses could be priced much higher or lower than the majority, which will affect our analysis. So you can detect outliers using statistical methods like IQR, interquartile range, or visually using box plot. So let's start by creating a box plot to identify outliers in the sales price. So now let's import Seaborn, import Seaborn as SNS. Okay. Import Matplotlib, import Matplotlib.titlo as PLT, as PLT. Okay. Now run. It will take some time while importing. Okay. Now our cell is run. So thereafter now we are going to create a box. Okay. Create a box plot to visualize outliers in sale. Okay. Sale price means our house price. So plt dot figure and fig size, let's take fig size equals to 8,6. Okay, let's take 8,6. Then we can give SNS SNS dot box plot x equals to house, x equals to tn Then we can do this. Df, we have the column float. What I can, let's see, price. Yeah. Now we are going to write here price. Okay, price, and then just plt dot show, and then we are going to write plt dot show, plt dot show. Okay. Oh, this plot will show any extreme values that might be considered as outliers. I don't think that we have outliers. So now let's understand how to handle with outliers. Once we have identified the outliers, we have several options. First we can do is remove the outliers. If they are present error or if they are present error or are not useful for analysis. So let's remove outliers. So we are going to remove lines. Okay. Remove young Q1 box D and price dot quantile. I am going to write 0.25, 0.25, 0.25. Okay. Let's take another also Q3. Okay. Q3 equals to DF price quantile and 0.75. So for finding IQR, we can we will minus IQR Q1 and P3. Okay, so P3 minus Q1. Okay, there we have done. And then we will see the lower bound. Let's see lower bound equals to Q1 minus 1.5. Okay, let's see um, the I2R and Q. Okay, but Q1 minus 5 into I2R. I think the upper one, go to the upper one equals to Q3 plus 1.5 into only Q times. Okay, let me use it. I'm not it. That's my that. DF equals to D meaning but again in bracket DF, then we will have price. Price, then we have is greater than or equals to lower bound, lower bound. Okay, and we then and house means DF price is lower than. Yes, is lower than equals to upper bound per tokens. If so, if the outliers, but be aware their influence will likely. In some cases, outlines represent value data points in the treasury homes. So now let's move into the another that is removing I removing irrelevant features. Sometimes data sets contain columns that may not be relevant for the analysis. For instance, ID columns or other unique identifiers might, might not provide useful insights during EDA. In our house price means price data sets, if we have an ID column, it may not get into our analysis, so we can drop it. Again, let's see the we don't have any relevant column, or we can say that about watering, wrestling, parking. Let's see, I want to drop it story, please. This is irrelevant. Okay, so we are going to do it, and we are this. So now let's do df equals to df dot draw columns stories. Let me check in reading stories. Stories. Yeah, stories. Df df dot draw columns equals to be right. Class with columns. Yeah. Okay, then we are going to do yes. Comma errors equals to ignore. Yeah. As you can see here that in our new data sets there is no columns for stories. Okay. So by removing irrelevant features, we streamline our data sets, making it easier to focus on the variables that truly matter for our analysis. So now let's recap data cleaning. At this stage, we have accomplished a lot. Here is a summary of what we have done. Remove duplicate rows to ensure there are no repeated entries. Fixed inconsistent or incorrect data, example, correcting invalid years for the garage. And third one is ensure correct data types for all columns, example, converting categorical features to the correct time. And fourth, we have handled outliers to prevent skewed results. And the fifth step what we did is drop irrelevant columns to focus on the features that matters. So the next is uh, univariate analysis. Okay, now that we have cleared and prepared our data set, it is time to begin univariate analysis. This type of analysis focuses on examining the distribution and characteristics of a single variable at a time. It helps us understand the key statistical properties of each feature in the dataset and uncover insights from individual columns. So let's understand what is univariate analysis. So first of all, univariate analysis refers to the analysis of a single variable. The objective here is to summarize and understand the distribution, central tendency like mean, median, and variability spread of a single feature. For each feature, we will look at things like how is the data distributed, normally, skewed, or uniform. Are there any outliers? What are the key statistics? Example, mean, median, mode. And the last we have, what do the visualizations like histogram, box plots tell us? Let's begin by analyzing the feature in our house price datasets. So the number one step one is univariate analysis of numerical variables. We will start by analyzing the numerical variable in the dataset, such as price, area, number, or bedrooms and bathrooms. These variables are continuous, meaning they can take on a wide range of numerical values. So let's understand the example one, that is analyzing price. So here I am going to write down that is analyzing, but before let me give hash analyzing, okay. analyzing, we are going to do analyzing price, okay. So now let's run this cell. Okay, here we have analyzing pricing. So price is the target variable we are trying to predict. So understanding its distribution is critical. Let's first look at the basic summary statistics and then visualize its distribution. So now let's I'm going to take out variable price summary equals to df, and I am going to take here price. Okay, price dot describe, let's see what comes. Price dot describe, and just print price summary. Okay, price summary df is not defined. Oh, I have to run all the x. Just a second, I am running all the cells so that it could run. Df is not defined. Okay, it will take some time. Yeah, so here you can, by dot describe, you can see our data: count, mean, standard, mean, minimum, 25%, 50%, 75%, and maximum. So this was the summary statistics for price. So now let's visualizing that price distribution. For that, what we have to do is, so now import Seaborn, as SNS. Then after we will import Matplotlib, import Matplotlib dot, okay, write down with me, pplot as PLT. Here PLT is an alias. Okay, so then after we are going to do is that, just write with me again, plt dot figure, and here we will provide fixed size equals to 8,6. okay, 8,6. yeah. Then after, now it's time to plot SNS dot hist plot df, and df. Then we will have our price column, price dot price, okay, comma KDE equals to true, okay. So now let's give the title, plt dot title. So here I am going to write distribution of house prices, distribution of house prices, okay. Then after, what we will do is, I am going to give the x label. So let's plt dot x label. Here I will give price, okay, price, okay. Then after y label also, plt dot y label. Here I will give y label, plt dot y label. Then after I will give here frequency. So here we have our frequency. Then we will just plt dot show, okay. Now learn, okay. After running, we got this graph. Here you can see, okay. So df dot describe means this function, as you can see here, dot describe. This function gives us a quick overview of the key statistics like mean, standard deviation, minimum and maximum values of the price. And the histoplot plot, this is used to plot the distribution of prices. Adding the kernel density estimated KDE provides a smooth curve to understand the density of price across the datasets. So here we have the key observation is that mean and median price. This value will tell us what the average house price is and whether the distribution is skewed, means when the mean and median differ significantly. And number 2 is distribution shape. From the histogram, we can observe whether the price data is normally distributed or skewed. Skewness can suggest potential outliers or irregularities in the data. And third, we have outliers. If there are any house with very high or low prices compared to the bulk of the data, they will be visible as long tails on either end of the distribution. So now let's comes to the second example, that is analyzing data. So here we will analyze the area of the houses, which is a key factor affecting price. We will look at the distribution and check for any patterns or outliers. Okay, so now again I am going to give here summary statistics. Okay, statistics for area. Now let's see area summary equals to d of area and let me write this, d of area dot describe. Okay, then after we will print area summary. Let's see. Oh, this is the summary statistics for area. Okay, now in the same way, let's visualize the area distribution. So for that, we are going to do is that plt dot figure. Again I am going to give fig size equals to 8,6. okay, 8,6. Then sns dot hist plot house sns dot hist plot means here we are going to give df area. Okay, area KDE equals to true. KDE equals to true, and the color equals to green. Okay, color equals to green. Then just I am going to give the title here. So let's write with me plt dot title distribution. Here we will pass distribution of house areas. Okay, distribution of house area. Let me fix this. Yes, here. Okay, and then we will do this there. Okay, okay. Now we have wrote the title. Now just wrote x label and y label. So write plt dot x label area which is in square feet. Area square feet. And the next we have plt dot y label. Okay, in which we will pass frequency. Okay, frequency. Then we will just write plt dot so now just run the say. Oh, Here we got another distribution of house areas. So now let's observe what we get. So number one is average area. The mean and median values will give us an idea of the typical house size in the datasets. And the second, outliers. Large or small house compared to the majority can be detected here, which may influence our analysis later on. And the last, we have skewness. A skewed distribution would indicate that most houses fall within a particular range of size with a few extreme values. Okay, here you can see that here majority of the house falls here. So now let's come to the another one, that is analyzing number of bedrooms. So let me give the heading here, means mark down. It's time to analyzing number of bedrooms. Okay, bedrooms. Yeah, just run this cell. Yeah, the number of bedrooms is another critical factor. While it's a discrete variable taking on the specific integer values like 1, 2, 3, etc., it's still important to understand its distribution. So now again we are going to find summary statistics for bedroom. Bedroom summary equals to df. Here we will have bedroom dot describe, and then after we are going to print bedroom summary. Let's see. Oh, let me yeah, here we have mean, count, standard deviation, minimum 25%, 50%, 75%, and maximum. So now let's visualize the number of bedroom distribution. Here what we are going to do is that plt.figure fixed size, okay, fixed size 8, 6. Then after what we do is that sns dot count, okay, sns dot count plot x equals to bedrooms, then comma data equals to df, okay, data equals to df, and then comma, and palette we have mutate, okay, mutate. Now just in the same way, let's give the title plt dot title, which I am going to do is that distribution of bedrooms in houses, okay, distribution of bedrooms in houses, okay. Then we will have label that is called x label and y label. plt dot x label number of, I think, books, yeah, number of bedrooms, then we will have plt dot y label, and in which I am going to pass count, okay, count. Here we have count in our y label, then I am going to use plt dot so. Here what we get, that unterminated number of O. So let me fix this first. Just a second. Yeah. Give me just a second. Now, yeah. Here you can see that on 3 number of bedrooms, we have the most of houses which have 3 bedrooms. So now let's come to the count plot. What we did in the count plot, where is count? Yeah, sns.countPlot. This function is ideal for visualizing categorical or discrete numerical variables. It shows the count of houses for each bedroom number. Here what we have the observation is that most common bedroom count. From the count plot, we can see how many houses have 2, 3, 4, etc. bedrooms. If we talk about outliers, houses with an unusually high or low number of bedrooms, example more than 5, must be outliers and may require further investigation. And number third is impact on our price. Later we will investigate how the number of bedrooms influences the price. So now let's analyze the bathroom. And here we are going to do is analyzing bathroom. Again I am going to give mark down analyzing bathrooms. Analyzing bathrooms. Like bedrooms, bathroom also play a role in determining the house value. We will analyze this variable similarly. So now let's bathroom summary. Here I am going to make a variable bathroom summary. Bathroom summary equals to df bathroom dot describe. Okay, now let's print bathroom summary. Let me print this bathroom summary. Okay, here we got dot describe function. Here we have count 530, mean, standard deviation, minimum 25%, 50%, and 25%, and in the last we have maximum. So now it's time to visualize the number of bathrooms distribution. Let's see plt.figure. Here we will pass again fig size as always. Here I am going to give 8,6. 8, let me give the here I am going to pass 8,6. So now let's write the sns dot count plot. X equals to bathrooms, df equals to data equals to df, and the last we have palette. Okay, palette equals to set 2. Palette equals to set 2. Okay, now plt dot title. Again as always I am going to give the title distribution of bathrooms in houses. So distributions of bathrooms, distribution of bathroom in houses. Okay, then now we are going to give label of x and y. Plt dot x label. Here we will have number of bathrooms, and then we will have plt dot y level count. Okay, so now let's plt dot so so here you can see that more than 350 houses have only one bathrooms. Okay, so now let's come to the key observation. Means most common bathrooms account. Here you can see the plot will show the most frequent number of bathrooms in the houses and potential outliers like bedrooms. If a house has an extremely high or low number of bathrooms, it might be an outlier. Okay, so now let's come to the another point, that is univariate analysis of categorical variable. So Here in our dataset, we also have several categorical variables such as main road, guest room, basement, air conditioning, parking, furnish, furnishing status, and prefer area. So now we will perform univariate analysis on each of these to understand their distribution. So now let's understand. Again, I am going to give markdown, that is yes, analyzing main road, okay. So now let's start. We are going to use count plot for main road. So plt dot figure bracket fig size, means figure size, I want by 8 by 6. So let me give 8 by 6 I want. So 8 by let just a second here, 8 by 6, okay, 8 by 6 here we have, okay, 8 by 6. Then after sns dot count plot, here we will pass x equals to main road, and data equals to df, then we will have palette, okay, which is cool warm, okay. So in the same way we are going to give the plt dot title, and then after x level and y level. So here I am going to give the title like main road proximity distribution, distribution, okay. So now let's do plt dot x level, here we have near main road, near main road, yes or no, okay, yes or no. And in y level, plt dot y level, here I will give count, okay, because we are going to count. So now let's print. So plt dot show show, okay. So here you can see that majority of the house has main road, okay. So here we have some key observation, that proportion of house near a main road. This tells us how many houses in the datasets are near a main road, which might influence their price or desirability. And the second, we have potential for predictive power. Whether being close to a main road increase or decrease the value of a house could be explored later in our analysis. So now let's come to the another example, that is analyzing furnishing status. So let's analyze whether the house are furnished, semi-furnished or unfurnished. This will give us an idea of the state of each house. So now let's again I am going to give markdown called analyzing furnishing status, okay. Now run this cell, then we will, from here we are going to code. Let's do with me plt dot figure comma how much wide and length, let me give but before giving figure size equals to 8 comma 6, okay. Here we have, then after sns dot count plot, here we are going to pass x equals to
furnishing status x equals to furnishing status furnishing status furnishing status furnishing status. Here we are going to give furnishing status, and after in data we are going to pass def, and in the palette here, oh just a second, palette we will have pastel. Okay, pastel. So now in the, as always, now just write the title x level y level. Okay, plt dot title. Here I am going to give distribution of furnishing status, and in the x level plt dot x level, here we will have furnishing status, and then we will have plt dot y level. Okay, plt dot y level. Here we will pass count as always, count plt dot count. Okay, now just plt dot show as always. Okay, and run the cell. So here you can see that semi furnished, furnished and unfurnished. By seeing this graph you can see that the number of semi furnished is much higher than furnished and unfurnished houses. So here we have the observation that most common furnishing status. By seeing this graph we can quickly identify whether most houses are furnished, semi furnished or unfurnished. So let's see effect on price. This is a factor we will investigate in our next step to see if it impacts the price. So it's time to recap univariate analysis. We analyzed both numerical and categorical variables individually to understand their distributions. Then after we use summary statistics, histograms and count plots to visualize these distributions and make key observations about potential outliers, trends and data characteristics. Then what we did is that this step provides a solid foundation for understanding each feature and prepares us to dive deeper into bivariate analysis, where we will explore the relationship between features. So now that we have completed the univariate analysis, now we will move on to bivariate analysis. In this step, we will explore the relationship between two variables at a time, one independent variable and one dependent variable. This is a critical step in exploratory data analysis, as it helps us identifying patterns and correlation between the features. So now let's understand what is bivariate analysis. So bivariate focuses on examining the relationship between two variables. It helps us answer questions like, does an increase in one variable correspond to an increase or decrease in another? Is there a linear relationship between two variables, or is it more complex? And another one is, are there certain combinations of variables that produce unusual or interesting outcomes? So in our case, we will focus on how the independent variables like area, bedroom, etc. relate to our target variables, which is price. So now let's come to the Visual Studio. Okay, this helps us understand which factors are likely to influence the house price the most. We will use different visual and statistical tools such as scatter plots, box plots and correlation analysis to identify these relationships. So the number one step is numerical versus numerical variables. So we will start by analyzing the relationship between numerical variables like area, bedroom and bathroom with price. These are continuous variables, so we will primarily use scatter plots and correlation coefficients to explore their relationships. So let's have example 1, that is, let me mark down. So the number one example we are going to understand is relationship between area and price. Let's see. So area is one of the most important factors in determining house price. Larger homes generally tend to be more expensive. Let's see how these two variables are related. So let's code. So we are going to scatter plot for area versus price. So now here we are going to do is plt dot figured. Here I am going to pass fixed size 8,6. Okay, let's see 8,6. Now then after what we are going to do is sns dot scatter plot. Here I am going to pass x equals to area and y equals to price. Okay, then after, just as always, data equals to df, and I want to color blue. Okay, blue, then I want color blue. So now just write the title, x level and y level. plt dot title. So now let's give the name area versus price. Okay, then after just write plt dot x level. Here I am going to pass area in square feet. Okay, area in square feet. Okay, so square feet. So then after now for y level, plt dot y level, in which I am going to give price. Okay, price, then just so like plt dot so. Okay, now just run the here you can see that our scatter plot, the more density is around 2000 to 6000. Okay, let's see what we get. So positive correlation, we expect to see a positive linear relationship between area and price. That is, as the area of a house increases, the price should also increase. Okay, and let's talk about outliers. We can visually identify any outliers where the price is too high or too low for the given area. And the third, we have strength of relationship. If the points form a clear upward trend, we can infer that area is strongly correlated with price. So to quantify with relationship, we will calculate the correlation coefficient. So now let's calculate the correlation between area and price. So here I am going to a variable called area price correlation. Correlation equals to df, in which I am going to pass area and comma price. Okay, price, area comma price, okay, then we will dot. Okay, so now let's print the area price. Okay, area price correlation. Here we got 1 and here 0.5 area and price. Okay, so this will give us a numerical value between -1 and 1 that represents the strength and direction of relationship between the area and price. A value closer to 1 means a strong positive correlation. Okay, so now let's understand the example 2, that is relationship between bedrooms and price. So now let's explore the relation between bedroom and price. Here we will use a box plot here, since bedrooms is a discrete variable count of bedrooms. So now let's start. For again I am going to give here markdown. I am going to relationship between between bedrooms and price. Okay, so as always, just write plt.figure, then in bracket just define your figure size, fig size. I want to give 8,6, and then I am going to, as always, sns dot box plot. This time I am going to use box plot. X equals to bedrooms, okay, bedrooms, comma, and y equals to price. So let's, as always, in data give df, okay, df, and palette, in palette we will have mutate. So it's time to define like plt.title, in which I am going to give bedrooms versus price, okay, room versus price. So print plt, but before I want to give plt.xlabel, plt.xlabel numbers of bedrooms, and then in y level plt.y level, in which I am going to pass price, okay, price, in which I am going to price. Let's just end it by writing plt.show. So here we have our box plot. So now let's understand the key observation, that price range for each bedroom count. The box plot will show us the price range for houses with different numbers of bedrooms. The middle line in each box, as you can see here, represents the median price for each category. And outliers, we may see outliers, houses with extremely high or low price for a given number of bedrooms. So number third is pattern. Ideally, houses with more bedrooms should generally be priced higher, but this might not always be the case, and the box plot will help us check for any unusual patterns. So now let's move into the another example, that is relationship between bathrooms and price. Relationship between bathrooms and price, okay. So now let's explore the impact of the numbers of bathrooms on the price of a house. Similar to bedrooms, we will use a box plot for this analysis. So first of all, you have to just define your figure, that is plt.figure, in which you have to define figure size equals to, as always, I am going to give 8 by 6, 8,6. Now sns dot box plot x equals to bathrooms, x equals to bathrooms, then after I will have y equals to price, as always, data equals to df, and palette we will have set 2. So plt.title bathrooms versus price. So now just write x label and y label as always. Plt.xlabel plt.x level, in which I am going to give number of bathrooms, and plt.y level, in which I am going to pass price. Okay, so plt.show, let's see what happens. Oh, now let's understand. Here you can see that more bathroom equals to more price. So first understand, let's see, is more bathroom equals to higher price. We will observe if the house with more bathrooms tend to have higher price. For example, house with 3 or more bathrooms may have a higher median price compared to house with only 1 bathrooms. So here you can see that this. Okay, and if we talk about outliers, again we will look for outliers where a house has too many or too few bathrooms for its price. And the last, if we talk about skewness, we can observe whether the price distribution for houses with certain numbers of bathrooms is skewed. So now let's come to the another example, that is categorical versus numerical variables. So again, let me give the markdown. Here I will give categorical versus numerical variables. So now we will examine the relationship between categorical variables and price. Categorical variables like furnishing status, air conditioning, and proximity to the main road can also have a significant impact on house price. We will use box plot to visualize these relationships. So let's understand the number one example between furnishing status and price. Here we are going to see the relationship between furnishing status and price. Okay, furnishing status, just a second, furnishing status, price and price. Okay, let me fix this. Furnishing status and price. Okay, so now let's analyze whether the furnishing status of the house, like furnished, semi-furnished, or unfurnished, affects the price. So now let's use box plot for this. So plt dot figure fig size equals to 8,6. Then after we are going to do is sns dot box plot x equals to for furnishing status, y equals to price, and then we will have data equals to df, and palette equals to cool warm. Pellets equals to cool warm. Okay, so now let's give the title, y level and x level. Okay, plt dot title, like furnishing status versus price. plt dot x level, furnishing status, plt dot y level. Now let's see price. So it's time to plt dot. So okay, so now it's time to key observation. Furnished houses are generally more expensive, so we expect the median price for furnished house to be higher than that for semi-furnished or unfurnished house. If we talk about the range of prices, we can observe the range of prices for each category. If the boxes overlap significantly, it may indicate that furnishing status is not a strong predictor of price. So now let's comes to the example 2, that is relation between proximity to main road and price. So now let's explore whether house that are near a main road have higher or lower price. So it's time to code. We are going to see just main road and price. Okay. So now plt dot figure here I am going to pass fixed size 8,6 then snx dot box plot x equals to main road comma y equals to price and comma data equals to just a second, I think yes, y equals to price, data equals to df and palette. I want to give set 3. So as always, just give the title and label of x and y. So write plt dot title proximity to main road versus price. Then after plt dot, just a second, let me correct it. Here I am going to just a plt dot price. Then after we will have indentation. Yes. Plt dot x level. Here I am going to give near main road and in bracket yes comma no. Okay. Then after plt dot y label price. Now just plt dot show. Oh, here we got our box plot. So let's see the key observation. So first, effect on main road proximity on price. We will check whether house near the main road have significantly different prices compared to those that are not. This can go either way. Houses near main roads might be explored expensive due to convenience, or they might be cheaper due to noise or pollution. And second one is medium price. The box plot will show the median price for each category, helping us determine if there is a notable difference. So now let's come to the another example, that is relationship between air conditioning and price. So now let's see relationship between air conditioning and price. I hope guys you are enjoying it, so please make sure you have liked the video. So relationship between, here we are going to see relationship between air conditioning and price. Okay, so let's see if the availability of air conditioning in the house affects the price. Air conditioning is considered as a desirable amenity, so it might increase the price. So here we are again going to take plt dot figure size. Let me check this, like sns dot box plot, sns dot box plot. In I want to pass x equals to air conditioning air conditioning, comma, y equals to price, and again comma, I will have data equals to df, comma, palette equals to pastel. I want to print plt dot title. In title I am going to pass air conditioning versus price. Okay, let's see. Air conditioning versus price. Okay, just a second. Air conditioning versus price, plt dot x level. Okay, so now here we are going to write plt dot x level, in which I am going to pass air conditioning air I am going to pass air conditioning. Okay, yes or no, and in plt dot we can say y level price, then we will have plt dot so. Okay, oh, here you can see that we got the answer because my what. So let's see the key observation of it. So first is price difference with air conditioning. We expect to see that houses with air conditioning generally have a higher median price than those without it. And second one is outliers. So now let's talk about the outliers, which is we may see some outliers in both categories where the price is unusually high or low despite the presence or absence of conditioning. Second one is outliers. We may see some outliers in both categories where the price is unusually high or low despite the presence or absence of air conditioning. So number third is correlation analysis. Let's see. So now let's take a broader look at how all the numerical variables in our datasets are related to each other and to price. We will use a correlation matrix to visualize this relationship. Okay, so let's start. Here I am going to change the figure size, plt dot figure, in which I am going to figure size I want to at that time 10 by 8. Okay, 10 by 8. Then after I am going to use the heat map sns dot, but before let me give the heading that we have is correlation analysis. Okay, SNS dot heat map. Here I am going to df dot core. Okay, then n not equals to true, n not equals to true, cmap equals to cool warm, cmap equals to cool warm, just a second, cmap equals to cool warm, and then we have cool warm, it's not cool warm, it's cool warm, cool warm. Then we have line width, line width equals to 0.5. So now let's give the title plt dot title, plt dot title, we have correlation matrix, correlation matrix, and then we have just plt dot show. Okay, could not convert string to float. Yes, I think here we have to define the column name, so you can define. So let's see the observation. Number one is strong correlation. We are especially interested in features that are strongly correlated with price, that is values close to 1 or -1. For example, we might see that area has a strong positive correlation with price, while other features may have weaker or even negative correlationship. And number second is multicollinearity. If two independent variables are highly correlated with each other, example bedrooms and area, this could lead to multicollinearity, which can distort model performance. We may need to consider removing or combining such variables when building our model. So now let's recap what we have learned from till now. So number one is bivariate analysis. In this, we examined the relationship between both numerical and categorical variables with price. We used scatter plots, box plot, and correlation matrix to visualize these relationships and understand the strength and direction of these association. This analysis helps us identify which features might be the most important predictors of house price and which one are less relevant. So now let's move into the multivariate analysis. Now that we have explored the individual relationship between two variables in bivariate analysis, it's time to move on to multivariate analysis. In this step, we will analyze how multiple variables interact with each other simultaneously and how these interactions affect the target variable, which is price in our case. Okay. So now let's talk about multivariate analysis. While bivariate analysis helps us look at the relation between two variables, multivariate analysis takes things further by examining how multiple variables influence each other. For example, we might want to see how area, number of bedrooms, and number of bathrooms together affect the house price. So why is it important? Multivariate analysis is crucial because in real-world scenarios, no variable works in isolation. The price of a house depends on a combination of factors such as location, size, and amenities. This analysis helps us understand how these variables work together to impact the final price. So let's dive into the implementation using house price datasets. Okay, let's jump into our VS Studio. So step 1, understanding the correlation matrix. Before performing any analysis, it's good practice to check the correlation matrix. This matrix helps us understand the linear relationship between multiple variables. So here I am going to write understanding the correlation matrix. Okay. So now let's run the program. So first we are going to make a variable name core matrix, in which I am going to df, in which I am going to price, comma, we have an area. Let me give these all in area. Then after we have bedrooms, then we have bathrooms. Okay, bathrooms. So now let's dot CORR. Okay, so df is not defined. Okay, let me run all. Yeah, df is not defined. Okay, here we will get answer soon. Okay, we got. So now it's time to visualize the correlation matrix with a heat map. Okay, so let me write visualize. Okay, visualize the correlation, the correlation matrix with a heat map. Okay, with a heat map. So now, as always, let's plt.figure, then pass figure size. As always, I am going to give 8,6. Okay, you can give it by your choice 8,6. So then after sns.heatmap bracket, then just pass core matrix inside of it, and then n note equals to true, cmap equals to cool warm. Okay, cool warm, and then we have line width. Okay, I am going to give 0.5. Okay, so now let's start plt.title. Here I am going to give the title name correlation matrix of features. Okay, correlation matrix of features. Then just close plt dot so, and now run the. Okay, here let me explain this. The correlation matrix tells us how strongly related two variables are, ranging from -1 to 1. Okay, a value close to 1 indicates a strong positive relationship. As one variable increases, the other does too. Okay, and the second point, a, a value close to -1 indicates a strong negative relationship. As one variable increases, the other decreases, while 0 indicates no linear relationship. So, for instance, if area has a higher correlation with price, it means larger houses tend to have larger prices. So, now let's use another one called using air plot to visualize interaction. So, let me give a title by markdown using pair plot to visualize interaction. Okay, to interaction. So we can use a pair plot to visualize how features interact with each other and with the target variable price. So let's write with me sns dot pair plot. Here I am going to give the df, in which I am going to pass price, comma, area, bedrooms. We have bedrooms, and then after Then after we are going to pass, okay, just a second, bedrooms, and in the last we have bathrooms. Okay, bathrooms. So now let's do plt dot so and just run the cell. Okay, let's see what comes. So a pair plot shows scatter plots for each pair of variables. It helps us visualize the distributions of variables and spot any interesting patterns or potential outliers. For example, we might see that house with more bedrooms tend to have higher price, but we might also observe diminishing returns where adding more bedrooms doesn't increase the price as much. So now let's come to the step 3, that is multivariate regression. Multivariate regression. Okay. So first we have to do is let's build a multivariate linear regression model to see how these variables combine to predict house price. So let's define feature and target. So I want x equals to df, in which I am going to pass area, area, comma, bedrooms, area, comma, bedrooms. Then we have bathrooms. Okay, bathrooms. So y equals to df, then again just write it down, price. So we have done. Now it's time to splitting the dataset into training and testing kits. So from, let me write, splitting the dataset, splitting the dataset into training, into training, and testing, into training and testing sets. Okay. Now let's import from sklearn dot model selection, import import linear, import linear, import linear. Why do we need to import linear? We have to import train test split. Okay. So now let me make this all first capital X, and then we have Y. Okay. Then we have X comma Y. Okay. But why we need to make them capital? We can also do. So now let them small. Okay. So now let's come and rewrite with me. Okay. X underscore train comma x test comma y train comma y test. Okay, equals to train test split, and in bracket just pass x comma y. So test size equals to, I'm dividing it by 70 and 30 by 70, so we have 0.3. Random state equals to 42. So now the time has come. It's time to training a linear regression model. Means training a linear regression model. So from scalar dot linear model import linear regression. Okay, then now just model equals to linear regression, and then we have model dot fit extend and y train, because we are just training the model. X train dot train x train comma y x train, then we have y train. Here we are modeling our model. So now it's time to predict. Okay, so predicting on the test set. So y pred equals to model dot predict x comma test. So now let's check. It's time to checking the r squared value. Okay, so from scalar dot matrix import r2 import r2 score. So just print here we are going to print r squared r2 square score y test y underscore test comma y pred y pred. Okay, so now let's run. Y pred is not defined. Oh, let me y pred. Okay, so now this code trains a linear this code trains this code trains a linear regression model to predict house based on an area, bedroom and bathroom. The R squared value tells us how well these features explain the variation in price. A higher R squared means the model is better at explaining the data, as you can see here. So now let's come to the outlier detection. So let's give me the heading outlier detection. Okay, outlier detection. So first understand what is outlier detection. Outliers are extreme values that deviate significantly from other observations in the dataset. They can skew the results and negatively impact our analysis. Therefore, detecting and handling them is crucial. So what are the steps in outliers? Let's see. So the number one step is visualizing outliers using box plot. So let me give the heading visualizing outliers using box using box plots. Okay. So now I think let me make this. Hmm. I can do one more thing is star star. So outlier detection. So we will use box plot to detect outliers in the numerical columns, particularly price. So SNS dot box plot SNS dot box plot bracket, then just pass x equals to df and price. Okay, price. Then we can do is plt dot title plt dot title plt dot title. Here I am going to give box plot for price. Okay, then just plt dot. So you forget comma. Again I forget comma where. E- Forget comma, but where? Okay. Yes. So a box plot helps us visualize the distribution of a variable and identify any outliers. In the plot, any point that lies outside the whiskers, the line extending from the box, okay, is considered as outlier. So outliers might occur due to error in data collection or actual anomalies. Example, a luxury house priced much higher than typical houses. So let's see how we can handle outliers. Handling outliers. Okay. Handling outliers. Once we have detected the outliers, we can handle them by either removing them or transforming the data to reduce their impact. So let's see. We are going here to removing outliers based on price. Removing, removing. Oh, let me removing, removing outliers, removing outliers. Okay, based on price. Okay, based on price. So now just Q1 equals to df, and we are going to take the column price dot quantile just pass 0.25 0.25, and we have q3 equals to df price dot quantile 0.75. Okay, so now let's find iqr equals to q3 minus q1. Okay, q1 q3 minus q1. So let's find lower bound lower bound equals to q1 minus 1.5 1.5. Okay, into IQR upper bound equals to Q3 Q3 plus 1.5 to IQR. Okay. So now let's make another variable called house data, or you can make df cleaned, house data cleaned equals to df equals to df. Then we are going to pass price 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 equals to lower bound lower bound. Okay. And we have df, and we are going to pass df price. We are going to pass the price. Then we are going to, oh, let me fix this. Yeah, now it is okay. Price do is less than or equals to upper bound. Okay. So now let's run the program. Let me print house. Okay, data cleaned. Here we have our data cleaned. Okay. we use so we use the interquartile range IQR method to detect outliers and remove houses that fall outside the acceptable ranges. So now let's come to the another point, that is data visualization techniques. So let me down this on the screen. That is data visualization JSON visualization techniques. Data visualization is a key part of EDA. It helps make patterns and relationships clearer by by representing data graphically. We have already used heat maps, air plots. We have already used heat maps, pair plots, and box plots. Let's briefly review some other essential visualizations. Number one is, let me write, number one, we have histogram. Okay, histogram, which helps to understand the distribution of a single variable. Second, we have scatter plot. Okay, scatter plot. This helps to identify the relation between two continuous variables. Okay, and the last we have bar plot. Okay, bar plot. This helps to compare categorical data. So now let's come to the correlation analysis. Okay, so what is correlation analysis? Let me first write correlation analysis. Okay, so correlation analysis helps us understand how strongly related variables are. High correlation between independent variables, also known as multicollinearity, can cause issues in models like linear regression. We already looked at the correlation matrix earlier. Let's now focus on how to interpret it. So number one is strong positive correlation. two variables increase together. Strong Second one is strong negative correlation. As one variable increases, the other decreases. And the last we have no correlation. No relation between the variables. In our data sets, we might find that the area and price have a strong positive correlation. So now let's come to the next part, that is feature engineering. Feature engineering. Let me correct this one again. So let me delete. Okay, I have deleted. So what is feature engineering? Feature engineering is the process of creating new features or transforming existing ones to improve model performance. For example, interaction terms, combining two or more features to capture their joint effect. For example, multiplying area by bedrooms might give a better predictor for price. Second one is log transformation. If a feature is skewed, you can apply a logarithmic transformation to make it more normally distributed, which helps certain model perform better. Let's apply a simple transformation, okay? So I am going to take df. Here I am going to take log price, log price equals to np dot log, np dot log df price. Okay. So now let's visualize the data. Just a second. So now let's visualize. Okay. SNS dot histplot, histplot df. Then I'm going to pass log, log price, df dot log price, log price. We are going to have log price. It's not log, it's log. Log price, comma KDE equals to true PLT, PLT dot title, in which I am going to pass log transformed, transformed price distribution, price distribution. So now let's show PLT dot show. NP is not defined. If NP is not defined, let me import numpy as NP. Okay, now it will run. Yes. So as you can see here, our code has run of about feature engineering. So now let's come to the summary. We have now completed a comprehensive EDA process. Here are the key takeaways. Univariate analysis helped us understand the distribution of individual features. Bivariate and multivariate analysis allowed us to explore relationship between variables and their combined impact on the target variable price. We used outlier detection techniques to identify and handle anomalies in the dataset. Then after we looked, data visualization techniques like heat maps, pair plots and box plot gave us a clear visual understanding of the data. Then we performed a correlation analysis to see how features are related. And finally, we applied feature engineering to improve model readiness by transforming and creating new features. So, by performing EDA, we have cleaned and prepared the data for machine learning, enabling us to build more accurate predictive models. This concludes our exploratory data analysis. This the data set is now well explored and you are ready to move on to modeling. Thanks, we will meet soon.